All right, welcome to this explainer. Today, we're literally putting on our hard hats and stepping straight onto the factory floor of enterprise integration. We're unpacking Chapter 1 of the SAP CPI Learning Map, which is all about the message model. If you've ever sat there and wondered how on earth massive global corporations get a slick, modern cloud storefront to talk flawlessly to a clunky 20-year-old on-premise billing system, well, you're in the right place. We're going to map out exactly how SAP Cloud Platform Integration, or CPI, makes that magic happen.
You know, there's a famous saying in enterprise IT, nobody built these buildings to talk to each other. And I want you to really stop and think about that for a second. Imagine your enterprise architecture as this sprawling city. A customer places an order in your web shop, right? Well, that single order has to reach the ERP system so finance can actually bill it. It's got to hit the warehouse so worker can pick it, and it needs to reach the customer's inbox as a confirmation. That's 4 completely different buildings, and they speak totally different languages. You've got JSON coming from the web shop, an IDOC for SAP, and maybe just a plain old CSV file for that legacy warehouse system. They use different doors, they keep different hours. The fundamental problem of enterprise IT is that nobody designed these systems to naturally communicate. Integration is the heavy lifting of making them talk anyway, reliably, without dropping a single order.
Okay, let's dive into this. Welcome to our first official stop on the learning map, the message model. To really get CPI, you kind of need to stop thinking about lines of code and start thinking about logistics. If SAP Integration Suite as a whole is this massive global logistics company, then CPI is its bustling central sorting hub. That is the one mental model absolutely everything else we discussed today is going to hang on.
So before we step out onto the sorting floor, here's our map for today. 1. The integration sorting hub. 2. Anatomy of an exchange. 3. The 5 structural elements. 4. Sync versus async delivery. And finally, number 5, simulating the flow. Let's get to it.
Starting right off with part 1, the integration sorting hub.
So what is it that we're actually building here? SAP Cloud Integration, which honestly everyone still lovingly calls CPI, is that central sorting facility. Inside this hub run a whole series of complex conveyor belts. In CPI terminology, we call these belts integration flows, or I-flows. Imagine a parcel representing a message full of data entering one end of the building. It rides along this conveyor belt past various stations that might relabel it, translate its contents, split it apart, or check it for errors, and then it leaves the other end perfectly packaged for its destination. As an integration developer, you're the architect designing those conveyor belts. And the hub? It just runs them day and night, handling failures gracefully so no parcel ever vanishes into thin air. All right, moving on to part 2, anatomy of an exchange. Now that we see the big picture of the factory, let's zoom all the way in on the actual parcel moving down our conveyor belt. When you look at the data traveling through your iFlow, it isn't just some messy block of code. It's actually a highly structured package made up of several specific components: the exchange, the message, the body, the headers, and the properties. Let's break down exactly what each of these are.
First up is the exchange. When a message enters your iFlow, CPI wraps it in a single master container called the exchange. Think of this as the complete bundle that a courier carries. It's not just the cardboard box, it's the box, the shipping label glued to the outside, and the private clipboard the courier is holding in their hand. Crucially, in any given flow run, there's exactly one parcel on the belt at a time. The exchange represents that entire traveling bundle.
Inside that bundle, we have the body. This is the actual business payload sitting inside the cardboard box, so the JSON order from the web shop or the XML invoice. The absolute most important rule to remember here is that the body takes up a single slot. If your conveyor belt runs the box through a translation station, the old contents are thrown out and totally replaced with the new ones. It is constantly being overwritten at each transformation step as it moves down the line. Now, what's really interesting about this slide is looking at the outside of that box, the headers. Think of headers as the shipping label glued to the outside of the cardboard box. This is your metadata. Things like a file name, a message ID, or a content type. They're visible without anyone having to rip open the box and read the body. And because they're slapped on the outside of the box, they travel with the parcel all the way to the receiver. In fact, when your flow calls an external system, these headers can automatically become the actual HTTP headers on the outbound call. The label goes right out the door with the box. In strict contrast to headers, we have properties. If headers are the shipping label, properties are the courier's private clipboard notes. This is basically your working memory for the flow, maybe a counter, a routing flag, or a value you extracted early on to use later. The fundamental difference here, these clipboard notes are strictly for the sorting hub.
I mean, you wouldn't hand a customer your courier's private, messy scratch pad, right? So they never get handed over to the final receiver. They stay safely inside the iFlow. Which brings us to part 3, the 5 structural elements. Let's move to and see how this builds. We've inspected our parcel, so let's step back and look at the physical machinery of the sorting hub itself. Every iFlow, no matter how incredibly complex, is assembled from just 5 structural building blocks. First, we have the participants, the external buildings on either end, like the sender handing us the parcel and the receiver getting it. Next, we've got the channels. These are the loading docks where the trucks pull up. You have to match the adapter on the channel to the language the participant speaks, whether that's HTTPS, SFTP, or an SAPI dock. From the channel, the parcel hits the start event. That's the green circle where it officially enters our facility. Then it moves into the integration process pool. This is the main sorting floor where all your routing and transformation steps actually live. And finally, it hits the end event, the red circle where the parcel is pushed out to the outbound loading dock. Understanding these 5 elements literally means you can read any CPI canvas anywhere in the world. Next up, part 4, sync versus async delivery. Before we can just turn this incredible machinery on, we have to define the rules of engagement with the sender. Every integration asks one fundamental question. Does the caller expect a reply? If they don't, we use the in-only pattern. This is fire and forget, or asynchronous. Imagine a massive logistics company in India, their warehouse system posting a midnight shipment update to your hub. It doesn't wait around for a response, it just drops the data and immediately moves to the next task. But if the caller needs an answer to proceed, we use in-out, or request reply. This is synchronous. Think of a UK retail e-commerce platform checking live inventory before confirming a customer's shopping cart. It hands the parcel over and waits on the line. If it doesn't get a response, the whole transaction stalls. You've got to design your conveyor belt to match that required pattern perfectly. And finally, part 5, simulating the flow. So, you've built your flow. You have your participants, channels, and transformation steps all set up. But what happens before we actually go live? How do we know this conveyor belt works without accidentally spamming a live production warehouse system with 1,000 dummy test packages? So, the crucial point is understanding the state of your iFlow. Listen, simply clicking save does not turn the machine on. A safe state just means your blueprint exists in the design time repository. To turn the conveyor belt on so it can actually accept real traffic, it must be in a deployed state, meaning it's actively compiled and running on the CPI tenant. But honestly, we don't want to deploy just to test a single step. And this brilliantly illustrates one of CPI's absolute best features, simulation. You don't have to deploy to test your logic. Right there on the design canvas, you can define a start point and an end point. You just manually feed a dummy JSON or XML payload into the body and hit Run Simulation. The system spins up a temporary virtual belt, runs your parcel through it, and spits out a little envelope icon. When you click that, you open the Exchange Inspector. You can literally look inside the box, read the shipping label, and check the courier's clipboard to verify exactly what happened at that exact point in the flow, all without a single piece of data ever leaving the building. It's a game changer. Well, we have covered a massive amount of ground today, from the logistics metaphor to the anatomy of an exchange, all the way down into the structural mechanics of the CPI sorting hub. But I want to leave you with a question to look at your own enterprise. If your internal systems were physical buildings, how many different languages would your IT courier need to speak today just to process a single order? That sheer complexity is exactly why a dedicated integration hub isn't some nice-to-have luxury, it's an absolute necessity. Keep that in mind as you process what we've learned today, and get ready because in Chapter 2, we are going to start actually wiring those buildings together. Catch you then!